In this video, we're going to go over simple probability. Probability of an event occurring is the number of ways an event can occur over the total number of possible outcomes. So here's a few examples. Tossing a coin. When a coin is tossed, there are two possible outcomes, heads or tails. We say that the probability of the coin landing on heads is 1, because there's only one heads, out of 2, the total outcome. The probability of the coin landing T, or tail, is 1/2 as well. So they have likely odds. Throwing dice. When a single die is thrown, there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6. The probability of any one of them is 1 out of 6. So let's say it asked for evens. You would ask, how many even numbers are there? Well, there's 1, 2, 3 numbers that are even out of the total. 3/6 is the same thing as 1/2. If it asks for a decimal, you type in 1/2 and get 0.5. If it wanted a percent, you would move the decimal twice and say that there's a 50% chance of rolling an even number. Some vocabulary that might come up throughout our probability unit. Theoretical probability, which is the ratio of the number of favorable outcomes to the number of possible outcomes if all outcomes have the same chance of happening. So like the coin is theoretical probability. They all have the same chance of happening. The dice, when you roll it, they all have the same chance of happening. Experimental probability is based on repeated trials of an experiment or number of successes over the number of trials. So this is where you actually go through and you do the experiment. Sample space is a collection of all possible outcomes of a random experiment. So when we listed all the numbers on the die, 1, 2, 3, 4, 5, 6, that is the sample space. The sample space for a coin would be heads and tails. That would be the sample space. So here's our first question. Is it possible to flip a coin and get 6 heads in a row? Even though, in theory, the probability is 50%. So this is one that we're going to go over another time. But if I flip one coin, the probability of landing on heads is 1/2. If I flip it again, it's still 1/2 probability of landing on heads. But it wants me to flip it 6 times. So 1, 2, 3, 4, 5, 6. It wants me to flip 6 times in a row and get heads. But the probability of that actually happening, you'd have to multiply all of these halves together in order to get all of these in a row being heads. So the real probability would be 1 over 2 times 2 is 4, 8, 16, 32, 46. That's the real likelihood. So 1 out of 46 would be 2% chance of getting 6 heads in a row. So that's very unlikely. Whereas this, just flipping it once, you have a 50% chance. What is the sample space for the spinner? Sample space means that I'm going to list the possible outcomes. Yellow, purple, blue, green, red, orange. So the total number of outcomes, there are 1, 2, 3, 4, 5, 6 possible outcomes. Which of the following is an outcome? Rolling a pair of dice. That's an experiment. Landing on red. That's an outcome. That's something that would actually happen. So landing on red would be one. Choosing 2 marbles from a bag. It doesn't specify what type. So once again, it's an experiment. None of the above. So which of the following is an outcome? Landing on red. Which of the following is an experiment? Tossing a coin. That would be an experiment. You're actually physically doing it. Rolling a 6-sided die. That's also an experiment. Choosing a marble from a jar. That's also an experiment. So all of the above would be the correct answer. Which of the following experiments does not have equally likely outcomes? So we're looking for one that's not equally likely. Choosing a number at random from 1 to 7. So if I was picking a number, 1, 2, 3, 4, 5, 6, 7, all of those have equal likely probability of being picked. Tossing a coin, heads or tails. Those are the only options. They're equally likely. Choosing a letter at random from the word school. So picking S, C, H, O, O, or O. Think about why this one is not equally likely. What part of this one is different from these ones up above? The difference is that the O's are more likely to be drawn than any of the other letters, so it's not fair. It's not a fair probability. A number from 1 to 11 is chosen at random. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. What's the probability of choosing an odd number? There's an odd. 2, 3, 4, 5, 6. 6 out of 11 total. What is the probability of choosing a vowel from the alphabet? There are 26 letters in the alphabet. A, E, I, O, U. We're not going to count Y. 1, 2, 3, 4, 5. 5 out of the total 26.